Good day everyone. Wastewater generated from industrial activity contain organic pollutant, suspended solids and other contaminants that can harm the environment if the discharged without proper treatment. Therefore, wastewater treatment is essential to protect a water resources which is aquatic life and public health. During our industrial visit to the Ajinomoto wastewater treatment plant, we observed the membrane bioreactor or MBR system used to treat industrial wastewater. The MBS system combines biological treatment using microorganisms with membrane filtration technology to efficiently remove pollutant from the wastewater. This presentation will explain the type of biological treatment process used, the role of a microorganism in reducing pollutants, the operational condition required for efficient treatment, and the environmental and sustainability benefit of MBR system. Type of biological treatment process that we use is MBR system. MBR stands for membrane bioreactor and it is an advanced biological wastewater treatment technology. And it is a combination of activated sludge process which is biological treatment and a membrane filtration which is solid liquid separation. It will break down the microorganism into a organic pollutant in wastewater, and it is also remove suspended solid bacteria and contamination, and it produce high quality treated water suitable for discharge or reuse and offer higher treatment efficiency than conventional activated sludge system, and it also commonly used for industrial wastewater with high organic content.
Hi, I'm Jinson, and today I will explain about how microbioorganisms work in salam in Ajinomoto. Microbioorganisms play a key role in wastewater treatment by breaking down organic pollutants, then convert complex organic matter into carbon dioxide, water, and inorganic substance, which helps reduce pollution level. This process efficiently lower both BOD and COD. At the same time, microbioorganisms convert pollutant into microbial biomass, which form sludge, and in sludge system, then form flows that improve solid liquid separation. In addition, microorganisms help remove nutrients such as nitrogen and phosphorus. It's also help improving overall effluent quality so that it meets it meets discharge standard, which is standard A. Overall, microbiorganisms are essential for efficient and sustainable water treatment.
Shashwini, and my metric number is AA242024. Today I'll be presenting the operational condition and equipment that support the effectiveness of the fermentation process. So, membrane bioreactor (MBR). This system depends on maintaining suitable environment condition for the microorganism because they are responsible for breaking down organic pollutants. So the treatment process must provide an environment that allows them to survive and function effectively. So there are two operational conditions that must be fulfilled. So the dissolved oxygen DO level should be around 2 to 4 mgl. This is because it supports the aerobic microbial activity. So microorganisms require sufficient oxygen to enhance the degradation of organic pollutants. Uh, it will simply convert into simpler and non-toxic compounds. So if the DO level is too low, microbial activity will decrease, and then the treatment efficiency will reduce. And another parameter is pH. It should be maintained around 7 to 8, which is near neutral conditions. So this provides optimum condition for microbial growth. If the pH level are too acidic or too alkaline, it can reduce the microorganisms' ability to remove pollutants such as BOD or COD. So there are three key equipments. First is MBR, membrane bioreactor. So MBR, this biological reactor, it provides a controlled environment where microorganisms can degrade organic contaminants, while the membrane filtration unit, this will separate the treated water from biomass and suspended solid. So it retains microorganisms for efficient pollutant removal. And so this system MBR, it will produce high quality effluent while retaining high concentration of microorganism within the reactor. Next is aeration system. Aeration system supplies oxygen required by microorganism into the wastewater. And the third one is monitoring and control instruments. These instruments will continuously monitor DO, pH, and other process performance. Next is environmental and societal benefits of applying fermentation technology in industrial wastewater treatment. So the first environmental benefit is that the process used at Ajinomoto effectively reduces pollutants like organic pollutant, BOD and COD before the wastewater is discharged into natural water bodies like the river. So it helps protect rivers and aquatic ecosystem from pollution. Next is the wastewater treatment used by Ajinomoto produces treated effluent that meets standard air discharge requirements, which is a more stricter wastewater discharge standard. And next is the sludge produced through that wastewater process is part of some of the sludge is reused as fertilizer. So instead of going for waste or for disposal, some of the sludge can be converted into useful resource for agriculture. Next is from societal benefits. Um, First is effective wastewater treatment protects public health through cleaner water resources. It prevents the release of harmful contaminants into the environment. So clean water resources benefits local communities, agriculture and industries. Lastly, it also supports sustainable industry development. That's all.
Next, the Salam wastewater treatment system demonstrates Ajinomoto's commitment to sustainable development and responsible engineering practice. The trade effluents meet standard A discharge requirements, ensuring minimal impact on the environment. In addition, about 30% of treated water is recycled and reused for landscaping purposes, which helps conserve freshwater resources. Furthermore, the sludge produced is not classified as gradual waste and can be used as fertilizer. This is because the wastewater mainly originates from food and fermentation processes, it containing biodegradable organic matter rather than hazard substance such as healthy method. This practice promote resource recovery, support the circular economy, and reduce environment impact.
Hi, my name is Mercy Sukumar and my metric number is AA240790. Now I'll be explaining the flow chart how a membrane bioreactor is working under wastewater treatment process. This flowchart illustrates the membrane bioreactor or MBR wastewater treatment process used to treat industrial wastewater. First, industrial wastewater generated from production activities enters the screening unit where large solids are removed to prevent damage to downstream equipment. Next, the wastewater flows into the equalization tank. This tank helps balance the flow rate and pollutant concentration, ensuring stable treatment condition. The wastewater then enters the aeration tank where microorganisms break down organic pollutants. Air is continuously supplied to provide oxygen, allowing the microorganisms to effectively reduce BOD and COD levels. After biological treatment, the wastewater passes through the MBI unit. In this stage, membrane filtration separates treated water from suspended solids, bacteria, and also biomass, producing high quality effluent. The treated water can then be safely discharged or reused for suitable application. Meanwhile, excess sludge produced during the biological process is sent for sludge treatment before being disposed of or further processed in an environmentally responsible manner. We have come to a conclusion. In conclusion, the membrane bioreactor or MBR system is an advanced and sustainable wastewater treatment technology that combines biological treatment with membrane filtration. The system effectively removes organic pollutants, suspended solids, and harmful contaminants, resulting in high quality treated water. Through our visit to the Ajinomoto wastewater treatment plant, we gained valuable knowledge about the role of microorganisms, the operation of MBR technology, and the importance of proper wastewater management in protecting the environment. The implementation of the MBR system demonstrates Ajinomoto's commitment to sustainable industrial practices, environmental protection, and responsible engineering. Overall, this technology plays a significant role in supporting clean water management and sustainable development. Thank you for your attention.